SK Pass International College. I'm so happy you are still following this channel. If you have not yet subscribed to the channel, kindly do so. Like the video and comment. We are still on hybridization and bonding. We started with some concepts already, so if you have not watched my previous videos, kindly do so before you watch this very video. Today we are going to move on. In this video, we shall be looking at the next type of hybridization. We finished talking about SP hybridization, SP2 hybridization, SP3 hybridization. In this video, we'll look at SP3D hybridization and SP3D2 hybridization. This will be the main types of hybridization we are going to look at. So, under this type of hybridization, we are able to state emphatically that it is formed as a result of missing an s orbital with a p orbital, which two hybrid orbitals are formed. And then the bond angle is 180 degrees. The bond angle is 180 degrees. With the second one, and the shape of this SP is linear in shape. SP2, we said that this type of hybridization is formed as a result of missing an s orbital with two p orbitals. So the new hybrid orbital form is, we have three new hybrid orbitals formed. And then the shape of SP2 hybridization is a trigonal planar. Under SP3 hybridization, we said this is also formed as a result of missing an s orbital with three p orbitals. Then, anytime we do that, the new hybrid orbital form, we have four new hybrid orbitals formed. The bond angle under this is 109.5. There are some molecules under that which exhibit the various types of hybridization. Now let's look at SP3D hybridization. SP3D hybridization. This is another type of hybridization, just like we did for the previous ones. This type of hybridization is formed as a result of mixing an s orbital. So this is one of the s orbital. You make s orbital with three p orbitals with a d orbital. So when you form this, four hybrid orbitals are formed. And look at how the formation goes. So we have this. So if you look at this type of hybridization form, how many hybrid orbitals are formed? We have 1, 2, 3, 4, 5. So the new hybrid orbital formed under SP3D hybridization, we form 5 new hybrid orbitals. So what name is given to that? These forms, you can, if you study this carefully, this 1, 2, 3. Let's look at this. This 1, 2, 3 forms a triangle. Okay, 1, 2, 3 forms a triangle. And after the triangle, there are two other. That is, look at this. 1 and 2. There are two of the hybrid orbitals at the axial. So we can say that this has formed what we call trigonal bipyramidal. So this is a bipyramidal. It's a pyramid. So here we cannot form only one angle. There are about two angles here, so we don't consider the bond angle much as compared to the others. So in this, you are not going to waste much time on the bond angle because there are about two bond angles here, 120 and then 109.5. So we don't have an exact bond angle. However, let's pick a typical example to demonstrate this concept. For instance, if you have PCl5, with PCl5, if you want to demonstrate the type of hybridization that is formed, because we said that this should be bonded with 5 hybrid orbitals. So all the examples we gave, we realize that the atom bonded is also having the same number of hybrid orbitals. So this is PCl5 because we said that after sp3d hybridization takes place, the new hybrid orbitals, we have 5 new hybrid orbitals formed. So if you see the chlorine, there are 5 of them. So what it implies is that this phosphorus must be bonded to 5 of these. Therefore, phosphorus becomes our central atom in this case. So let's look at this. Phosphorus, which is atomic number 15. If you want to write a configuration, it's going to be 1s2, 2s2, 2p6, 3s2, 3p, I think 3, yeah. So let's calculate and see whether it's up to 2 plus 2, 4 plus this, 10, 12, 15. So that is for the electronic configuration for phosphorus. We've said something in chemical bonding that anytime we are dealing with chemical bonding, we only concentrate on the valence electrons and not the core electrons. So it is only these that undergo bonding. So if we take phosphorus, we are only interested in 3s2 and then 3p3. So this is the ground state electronic configuration. And because phosphorus is bonded to 5 of this chlorine, we have to manage and get 5 of them. So let's look at the example here. This is an s orbital. There are 2 of the electrons here. This is a p orbital, a degenerate orbital. And there are 3 of them. So when you meet 1s and 3p, we have not satisfied the rule because there is a d orbital. So with this issue, we need to extend and bring the d orbital. This is d orbital. It is also a degenerate orbital with 5 subdivisions. So looking at the first d, we need to promote this electron from this lower energy to this. Why are we doing that? We are doing that because chlorine, the PCl5, the chlorine here has 5 atoms. And here, when we want to calculate, we have 1, 2, 3, 4. There is the need for another orbital. Therefore, we need to promote this electron from this to the other orbital, the d orbital. And that brings about the excitation. So in the excited state, we are going to get something like this. This is 1s and 3s. Then the next one, 3p, 3 of them. Then when you pick the d orbital itself, 1, 2, 3, 4, 5. Okay. We have promoted this electron from this place to this place. So this is also having an electron. So you can see in the sp3d, you have mixing an s orbital. This is an s orbital, this is a p orbital, and this is a d orbital. And as soon as you mix this, the type of hybridization you are seeing here is sp3, because 3 of the p orbitals, d, sp3d hybridization. So how do you draw this? Okay, so let's look at the phosphorus, which is our central atom. So this is our phosphorus. And this is having 5 of the hybrid orbitals. So one is here, like this. There's another one here, another one here like this. And they are pi, the pi's are here. Okay, like this. So this is forming. Let me draw this wall. There should be a repulsion. They should stay far away from each other. Okay, so this is what we are getting. So this is the shape. But however, they are chlorines. We have PCl5. The chlorines here, they are also having a shape. So you can have this. Another one here. So from here you can see they all bring 1 electron each. This one to this one, okay, and Finish with the black. 1 electron each. Okay. Then there's a pairing up here. They are forming a bond, a covalent bond. Okay. So this is what you see. If you want to draw the actual thing showing the bond, this is exactly so anytime two of these electrons are shared, as a single bond like this formed. So there are 2 electrons. Any line you see represents 2 electrons. I think we did that in our chemical bonding. So we are having chlorine, 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 chlorine. Sorry, so this is not B, excuse me. This is P. So this is PCl5, and it's another type of hybridization. Okay, so that is it. Basically, if you have any questions, you can comment. I'll talk about the last type of hybridization. Last type of hybridization. You can try that on your own. The last type, you are going to try that on your own. So look at this. sp3d2. You can try that on your own. In this case, you are going to mix an s orbital with 3p orbitals with 2d orbitals. A typical example is SF6. A typical example is SF6. So with SF6, if you go through all the procedures, this is the central atom. You can try that on your own and comment. If you are not able to do it, let me know in the comment section. SF6 is going to give you something like this. This is my sulfur. Okay. So I'm having this. Okay, so it's going to look like this. This is my fluorine. This is my fluorine. If you do it well, you're going to get something like this. So the shape of this is what we call it is tetrahedral in shape. Okay. This is a tetrahedral shape. So this shape is called tetrahedral. So SF6 is octahedral, sorry. Octahedral. Let me write it here. Octahedral in shape. So this is octahedral in shape. And the new hybrid orbital form, we have 1 plus 3, 4 plus 2, 6. 6 hybrid orbitals are formed. So a typical example of this is SF6. You can try your hands on others. Thank you for watching this video. But mind you, in our next video we shall be looking at sigma bonds and pi bonds. But before we get to our next video, when we talk of sigma bonds, they are formed as the axial or the head-on overlap of atomic orbitals. I'll give a full video on that. And then the other way around, they are formed as a lateral formation of the p orbital. They are formed under p orbital. When 2 p orbitals come side by side, that is what we call pi bond. So see you in my next video. Thank you for watching this video and subscribe to the channel.